Hi guys, quick revision video on mixtures, solutions, and solvents in case you've mixed it. Oh, sorry, missed the class. That wasn't intentional. I'm sorry, that's terrible. Moving on. Mixture contains more than one substance. The substances are mixed together and not chemically combined. Air is a mixture of nitrogen, oxygen, and small amounts of other gases being carbon dioxide and others. So let me just write that down. Carbon dioxide and O2 and nitrogen. Notice how these are compounds in their own right, but compounds can form a mixture, right? Another such example is salt water, where it's NaCl plus H2O. Now NaCl is your salt and H2O is water, but they can mix together, just forming a solution, right? So we won't focus too much on compounds on their own. So this chapter is unnecessarily sometimes confusing, but over time we'll get a stronger understanding or better understanding of what compounds are, and we can differentiate them from mixtures. It's important for now to realize that H2O is not a mixture of hydrogen and oxygen, it's a compound and it's known as water. So compounds can be pure, mixtures by their very nature are not pure. Here's an example of a solution. A solution is when a solute dissolves in a solvent and a solution is formed. The idea is when something dissolves in a particular liquid, it forms a solution. Now, whatever you're trying to dissolve is known as a solute, and whatever you end up dissolving it in is a solvent, and the things combined, could be multiple things, could be salt here as well. All of those things combined are known as a solution. So in salt water, the salt would be the solute and water would be the solvent, and together they're a solution. Now here's another mixture where it doesn't form a solution. Chalk, when you mix it in water, most of the powder eventually sinks in and does not dissolve. Why is this so different from sugar? Because the particles are very different and they don't easily end up dissolving in the water. So they're still separate. Is it still a mixture? Yes, because they're together, and if you just want water or just want chalk, it's difficult to extract one of the two. But they're not dissolved or chemically bonded. Okay, let's move on. So here's for the first time, I think we're introducing the idea that something solubility is a range quantity rather than something dissolves or doesn't dissolve. The idea is that there's a particular amount of substance that can dissolve in water at a particular temperature, right? So if you look at over here, for every 100 grams of water, you can only end up dissolving silver chloride at 0.0002 grams worth of it. So that's almost, so some of it does dissolve. It's not like it's not soluble, but it's barely, it's negligible to the point we ignore whatever dissolves. Calcium carbonate. Now this is chalk, right? So it barely dissolves as well, but you can tell that it's dissolved in water. Like, it's so minute in amount, like 0.001% of the actual substance you end up using ends up dissolving. So very negligible. As opposed to sugar, which dissolves a lot. You can have up to 91 grams of sugar, almost the weight of the water, dissolved in that much water. That's interesting, right? And you can have calcium nitrate or silver nitrate dissolved in water which exceed the amount of water that's already present. That's crazy. Okay. But we won't be tested too much. This is just a foreshadowing for topics to come where we discuss ideas that, okay, solubility is not like something's insoluble or something is, and other things are soluble. Solubility is more considered as a range where some things dissolve very less and are considered insoluble because the amount that does dissolve is negligible. For example, silver chloride. Other things are considered soluble because a lot of it ends up dissolving. Now notice how it says 25 degrees Celsius. That'll be important for the next few slides. You can encourage something dissolving in water. How so? You start adding it to water, right? So you start mixing it and you'll realize over time the extra sugar after, let's say, the 5th tablespoon, it doesn't dissolve because it's reached its limit. Remember in the earlier slide, it said only about 91 grams can dissolve in 100 grams of water. Okay. So maybe you've reached your 91 grams with 5 tablespoons and the extra is not dissolving. But it said 100 grams of water at 25 degrees Celsius. If you heat the water, you encourage more particles, you increase the capacity of water to dissolve more compounds in it, right? More different things in it. So sugar ends up, whatever which wasn't dissolving earlier, when you heat it, it starts dissolving. That's why when you're cooking, more often than not, you heat the water towards boil. When it starts boiling, you start putting ingredients in because you don't want to waste your time. Another good example for this is when you put tea leaves or green tea in cold water, it doesn't do anything because it's not dissolving. Like the constituents of the tea, whatever the ingredients are in the leaf, right? Now when you heat it and when you throw it in, they dissolve a lot more. So all of that comes out of the leaves and mixes with the water, forms a solution. Okay. Now this idea is really important for crystallization. If you understand this properly, you can understand solubility, crystallization really well. The idea is, once you heat it, all the extra sugar dissolves. But when you cool it, water's capacity to dissolve will go down as well. So you have extra sugar dissolved, and water, if you leave it to cool, it's about to get less soluble. So once you leave it to cool, it's going to form these little particles at the bottom. Now they form tiny little crystals of sugar because the water is ejecting them back out. It says, okay, I can only take care of 91 grams of sugar at this point, nothing more, right? So it starts ejecting all the extra sugars out, and because sugar is heavier, it ends up forming crystals at the bottom. If it was less dense than water, it would have floated to the top. But it's just at the bottom where it crystallizes. And this method is something which you end up using for crystallization later on. I hope you understand this. And if you don't, just read a bit more about it in the notes or rewatch this little segment. This will really shine light as to how crystallization takes place. Let's move on. A solution is saturated when it cannot dissolve no more solute at that temperature. So a saturated solution of sugar is something that has the maximum amount of sugar at whatever temperature you're referring it to. Normally you'd refer it to room temperature, so it can't dissolve anymore. Okay? That's what saturated means. You'll see this word thrown around a lot, and you should understand what it means. A soluble solid usually gets more soluble as temperature rises. Okay, we discussed this a little bit. Let's move on. Now we're discussing, if you haven't picked up, we're discussing certain points, certain physical characteristics, which we'll end up using those very properties to use them to separate different mixtures. Solubility, understanding of solubility is important because we'll see that in crystallization, even in filtration. Okay? Volatility is shown up in fractional distillation and just distillation on its own. Okay? Volatility, our substance is volatile if it evaporates easily. The more volatile it is, the more it evaporates easily. Why does it evaporate easily? Because very likely its boiling point is very close to room temperature, right? And why is it close to room temperature? Why is it so easy for it to boil? Well, it's just a sign that the forces between the particles are weak. I mean, just straightforward kinetic particle theory. More stronger forces, harder for us to boil it. Less stronger forces, easy for us to boil it, right? Just to note, you don't have to I won't ask questions about volatility, but understanding this will again help our separation techniques in the next set of videos. Solubility, or something that's soluble, I think a better way, let's change this question to, solubility. Solubility. Define solubility. And let's define it at the bottom. ठीक है. Solubility is the measurement of how much a substance will dissolve in water. ठीक है? And something that is insoluble is something that does not dissolve in water. An aqueous solution is something that's using the solvent as water, right? Aqueous comes from the word aqua, which means water. All right, I'll see you guys in the next video.